Welcome back to the channel. Today we're going to finish construction of the crankshaft. So the first thing we're going to do is we're going to set this up in the lathe. This is a piece of 5/16 drill rod, and it's just rough cut off. So we're going to square up the ends, and then we're going to turn this down to 281, and then we're going to drill and tap it for the grease cup, and then we'll machine it to the final length, and then this will get inserted in here from this side, and this will get soldered in. So we're also going to take the same piece of 5/16 drill rod that I've got here for the crankshaft, and it's just been rough cut, so we'll square this end up here, and then I'm going to go ahead and counter drill both ends just in case we need it at any point. Shouldn't need it, but I like to have them in there in case we need to set this up in between centers for some reason. And then one thing we're going to do different from the plans call for 2 roll pins that go through the flywheel through this crankshaft to hold it on, but I'm going to use a key for that. So we're going to go ahead and machine the keyway into this before we solder it on. So once we get the keyway in this, and then we get this piece turned down and drilled and tapped, then we'll get everything assembled into here, and then we'll get it all soldered up, and that will finish up the crankshaft. Okay, so we got the pin finished up here for the connecting rod, and we got the keyway cut and the crankshaft, and then we got everything soldered together. So I've been using this Harris Stay Bright kit. It comes with the flux and silver solder, and it's been working pretty good. I like to cut a small, wrap a piece around here and cut it off that fits around here, and then leave that on there instead of heating it and trying to apply the solder afterwards. So put the flux on first and then put that around there, and just be sure that you heat up the piece of metal and try not to heat the flux, or excuse me, try not to heat the solder. Heat the piece of metal and let the piece of metal melt the solder. And then you could see in the video I had it all clamped down to a fixture plate because stuff has a tendency to move around when you're soldering it. So we need to keep this perfectly straight here. We don't want it to move any when we solder it. So I clamped it down to the fixture plate when I was soldering it to keep everything straight. It all still fits good. And I went ahead and cut off a short piece of key stock for that. So next thing we're going to do, we're going to drill and tap these holes for the oil cups. And then generally I like to follow the plans through the book as they come, but in this case we're going to jump ahead a little bit. We're going to go ahead and make the oiler cups for the crankshaft. I've got this piece of scrap that's for a MIG welder. It's the tip off of it, and it's wore out, but I think I can get both of the oilers out of this. We'll see. So we'll get this drilled and tapped and then get this set up in the lathe and machine the oilers. They're pretty simple machining. Gets machined down to a 632 screw thread on the end, and then a small section that's 250, and then a little bit of a taper, and then the body gets turned down. So it's all turn operation that we can do in the lathe. Okay, so I got the oil cups finished up, got them installed. They look good. And I've also got the crankshaft in here. And you want to make sure that this spins free and easy. You definitely don't want any kind of bond in here because that's going to be friction. It's going to make it harder to start, harder to run. So if you've got any bond in here, try to get that fixed before you go any farther. So since we're jumping around a little bit, I'm going to go ahead and make the ignition cam that will trigger the points. It's a pretty simple piece to make. So I've got a scrap piece here we're going to start with. It's just a rough piece, already got a hole in it. So we'll get a hole in the middle, the correct size, and then turn the OD down, and then it gets a flat machined on it, and then it gets drilled and tapped for a 632 set screw. So we'll get this set up in the lathe and start machining on it. Okay, got the ignition cam finished up and got it installed. And you can see how it's going to activate the points. There, the points are open. Comes around. And they're closed. So, one note on this, if you're following along and making one of these engines yourself, which hopefully you are, I don't particularly like the way this is dimensioned on this flat. It gives a width of 3/8 of an inch, 375 thousandths, but that's a hard dimension to measure from flat to flat and get it accurate. So checking the model, the CAD model, and then doing a sketch in Fusion 360 just to verify the amount that you cut off of this flat. If you turn it to 688, you're exactly at 688 on the OD. You're going to cut off 56 thousandths and you'll be left with 632 thousandths, which is something that you can measure. Or if you zero your cutter out, you're cutting off 56 thousandths for that. And that'll again leave you a flat of 3/8 of an inch wide. So that's going to do it for this episode. Come back next time. We're going to start turning this massive chunk here into the flywheel. Thanks for watching.